Hello, I'm Sylvia Knight, Head of Education at the Royal Meteorological Society. In this series of short films, we're covering some of the background information that geography teachers may find useful if they're teaching weather and climate at secondary level. This is linked to the Weather and Climate Teaching Guide with accompanying classroom resources which you can find on our website, METLink. In this film, I'll be looking at the climate crisis, tipping points, the cost of climate change, climate justice, and attributing extreme weather events to climate change. In October 2019, the Guardian newspaper stopped referring to climate change and used the terms climate emergency or climate crisis instead. More generally, 2019 was a year when the rhetoric surrounding our climate system ramped up significantly, driven in part by the IPCC's 2018 1.5 degrees Celsius report and the contributions by Greta Thunberg, who inspired her generation, and Extinction Rebellion. Other recent terminology includes the term climate catastrophe, which was introduced by Sir David Attenborough. Abrupt climate change is defined as a large-scale change in the climate system which takes place over a few decades or less and is anticipated to persist for at least a few decades and causes substantial disruption in human and natural systems. A number of components or phenomena within the Earth's global or regional climate system have been proposed as potentially possessing critical thresholds, referred to as tipping points, beyond which abrupt or non-linear transitions to a different state occurs. Two types of tipping points exist. One involves a rapid transition, like what happens when a canoe rocks back and forth. Eventually it flips over, but it's not irreversible. The other type of tipping point is irreversible if the recovery timescale is significantly longer than the time it took to reach a new state. For example, a skier going downhill, either on a steep or a gradually sloped mountain, so skiing quickly or slowly, but once the ski is at the bottom, it takes a long time for that skier to walk back up the mountain. So to some extent, it can be said that most aspects of climate change due to carbon dioxide emissions are irreversible due to the long residence time of carbon dioxide in the atmosphere. The term tipping point is therefore usually used in the context of an irreversible change. Aspects of the Earth's climate system have tipped in the past, and projections suggest that an increase in greenhouse gas concentrations may lead to future tipping points being reached. This is a map of potential tipping point elements in the climate system. The subsystems indicated, including the cryosphere, the circulation of the atmosphere, and the oceans and biomes, could exhibit threshold-type behaviour in response to anthropogenic climate forcing. So where a small perturbation at a critical time or place qualitatively alters the future fate of the system. They could be triggered this century and would undergo a qualitative change within this millennium. The map doesn't include systems in which any threshold appears inaccessible this century, for example, melting of the East Antarctic ice sheet, or where a qualitative change would appear beyond this millennium, so for example changes in marine methane hydrates. Question marks indicate systems whose status as tipping elements are particularly uncertain. Arguably, positive tipping points that have already happened could include the development of renewable energy and that becoming cheaper than fossil fuels in some instances, or of electric vehicles, or a change in public opinion about climate action. As the atmosphere and oceans warm, sea ice melts, which exposes a much darker ocean. This triggers a positive feedback by lowering the albedo of the ocean's surface and leading to more of the sun's light being absorbed, amplifying the warming. It was thought that Arctic sea ice could display a tipping point if the ocean's surface became so warm that it prevented sea ice from forming in the winter. But this is no longer thought to be the case. As the climate warms, there will be less sea ice in the Arctic in all seasons, but it isn't a tipping point because the system hasn't flipped into a new state. In any year, it would be possible for sea ice to form in the winter. It is likely that the Arctic Ocean will become nearly ice-free in September before 2050, although some ice may persist along northern coastlines. If the amount of carbon dioxide in the atmosphere falls, the loss of sea ice could be reversed within years to decades. The effect of rapid changes to Arctic sea ice may have consequences throughout the climate system, particularly on cloud cover. In late 2018, the Intergovernmental Panel on Climate Change published its special report on global warming of 1.5 degrees Celsius. The report highlighted a number of climate change impacts that would be avoided by limiting global warming to 1.5 degrees compared to 2 degrees Celsius or more. For instance, by 2100, global sea level rise would be 10 centimetres lower with global warming of 1.5 degrees compared to 2 degrees Celsius. The likelihood of an Arctic Ocean free of summer sea ice would be once per century with global warming of 1.5 degrees Celsius compared with at least once per decade with 2 degrees Celsius. Coral reefs would decline by 70 to 90% with global warming of 1.5 degrees, whereas over 99% would be lost with 2 degrees. Every extra bit of warming matters, especially since warming of 1.5 degrees Celsius or higher increases the risk associated with long-lasting or irreversible changes, such as the loss of some ecosystems. Allowing the global temperature to temporarily exceed or overshoot 1.5 degrees would mean a greater reliance on techniques that remove carbon dioxide from the air to return global temperature to below 1.5 degrees Celsius warmer by 2100. The effectiveness of such techniques are unproven at large scale, and some may carry significant risks for sustainable development. Limiting global warming to 1.5 degrees Celsius compared with 2 degrees would reduce challenging impacts on ecosystems, human health and well-being, making it easier to achieve the United Nations Sustainable Development Goals. Although this was not stated in the IPCC's report, some media reported the findings of the report with headlines such as "We have 12 years to limit climate change," a figure that was taken up by organisations around the world. It stemmed from the IPCC's conclusion that limiting global warming to 1.5 degrees would require rapid and far-reaching transitions in land, energy, industry, buildings, transport and cities. Global net human-caused emissions of carbon dioxide would need to fall by about 45% from 2010 levels by 2030, reaching net zero around 2050. There are, however, many possible pathways to emission reductions, and the final temperature change depends on which is taken. Do emissions fall gradually or abruptly? Do they carry on rising? When are the reductions made? So although such headlines did arguably generate a significant amount of attention and action, they can be less than helpful if they give rise to fear and a feeling of helplessness. Greta Thunberg started her school strike for climate in August 2018. By December, 20,000 students around the world had joined her. Extinction Rebellion was similarly formed in 2018. There's a widespread misconception that preventing climate change will cost too much. Climate change poses numerous threats to the UK, causing damage to human welfare and the economy through agriculture, flooding, ecosystems and health. The net zero transition is actually expected to have a net benefit of around 4% of UK GDP. Globally, climate change may reduce global income by about 19% over the next 25 years, and more so subsequently, unless emissions are drastically reduced, whereas the global cost of limiting climate change to 1.5 degrees is, at most, projected to be 4.2% of GDP. The sooner action is taken to reduce climate change, the greater the financial benefits. Another misconception relates to the cause of recent warming. The IPCC concluded in 2021 that the 1.1 degrees warming that the globe has experienced since 1850 was exclusively due to human activities. The concept of climate justice explores the fact that the impacts of climate change are disproportionately experienced by marginalised or low-income communities who've contributed least to global warming. Financial mechanisms, such as the Green Climate Fund, accelerate transformative climate action in developing countries, and loss and damage payments are made to low-income countries when climate change mitigation and adaptation have failed and damage is caused by climate change-linked extreme weather. Our ability to say whether or not an extreme weather event was due to or exacerbated by climate change is improving rapidly, and you'll now hear attribution information in the days following an extreme weather event, such as a flood, a heat wave, a drought or a storm. This map, made by Carbon Brief in 2024, shows the attribution of 750 global extreme weather events, and both Carbon Brief and World Weather Attribution are good sources of information about more recent events. There are many other useful sources of data and information, some of which we've given in the text below. In the next film, we'll look at high pressure systems, anticyclones.